Problem 14 is curium-246 decays at a rate proportional to its mass. If the mass was 197.9 milligrams 1.4 thousand years ago, and the current mass is 161.2 milligrams, what is the decay rate per 1,000 years? So when we see that curium-246 decays at a rate proportional to its mass, we know that we're probably going to use this equation. N equals N naught times e to the power of kt. And so we have all these variables except for k, so we know that N is going to be equal to the mass after the decay, which would be 161.2 milligrams, and naught will be 197.9 milligrams. E we already know is 2.718 approximately. Then after that we know that T, well we actually don't know T, so we'll come back for that, but the actual unknown is K, and so that's our unknown. And so T, actually, since we have two times, we have 1.4 thousand years ago and 1,000 years ago, we actually have to find the ratio between those times. So 1,400 divided by 1,000 will actually be 1.4, which is our actual time. When I say actual time, I mean that's the time we'll put into the equation, because we have to put a ratio in order to solve. If we have these values, we can start inputting them into the equation. So N, as we see here, is 161.2 milligrams. So put this down here, 161.2 is equal to 197.9 times E to the power of K, and then the T we'll put in is 1.4. And so now what we can do is divide both sides by 197.9, and that's going to give us, as we'll see here, 197.9, 197.9. That's going to give us 0.8146 is equal to E to the power of kt, or sorry, k times 1.4. Now, since we have that E here, what we can do with that E is take the natural log of both sides in order to get rid of that. So ln of 0.8146 is going to be equal to getting rid of that E. That's going to be k times 1.4. The natural log of this number, 0.8146, is going to be negative 0.2051, and that's again equal to k times 1.4, and then dividing both sides by 1.4. That's going to give us our almost final answer for k, being that k is equal to negative 0.1465. And that will fit right back into that equation. So what we can also do for this answer is turn it into a percentage of decay. And we know it's decay, obviously, because it's negative. That's our answer. But what we can do is turn this over here, bring it over here, and give us the answer of 14.65% decay per every 1,000 years. And that's our final answer.